Okay, welcome everybody to this ice tracking webinar roundtable discussion. We weren't really sure what to call it, but
Hi.
we wanted to give people, in the depths of winter, give people an opportunity to think about lakes and learn about lakes. And so my name's Susan Gallo. I'm with Maine Lakes, and we have Tristan Taber's our presenter from Lake Stewards of Maine. The two organizations have gotten together on a bunch of different initiatives in the in the last year, I'd say, a couple of years. We have a joint lakes conference that we did last year, and we're doing again this year. We're coordinating on some watershed survey grants and a couple of other projects. And so this is a joint effort between our two organizations to reach out to all of you, connect with all of you. So thank you so much for being here. Tristan's going to take about 20 to 30 minutes at the most to present the data that he has been working on. Uh, we'll plan to save your questions. We'll ask them all if we'll have our discussion when he's finished, but feel free to when we get to that point we'll use raise hands, but you can also type in questions in chat. I'll kind of keep an eye on that. And yeah, so the goal is a little bit of presentation and then some discussion among all of you to hear from you. So I think, did I
All
miss
right.
anything, Kristen? I'll just pass it on to you.
I think that's good. I will just say that our next presentation, and we'll
Oh, thank you.
remind you at the end, is going to be Karen Wilson from the University of Southern Maine. She's going to be talking about crayfish, both the native and the invasive, and the project that she works on with tracking some of those species. And that is March 15th
March 7th.
at 5, March 7th, sorry,
March
March
7th
7th at 5
at
p.m.
5.
So there we go.
Yes.
All
Yes, and
right.
apologies to everybody for the confusion over the time.
Yeah.
But well, yeah, 5 o'clock. So yes, thank you for remembering that.
All right. I'm gonna share my screen here. So, and look at that there. All right. So, thanks for joining me, everybody. This talk is going to be really focused on sort of the overview of understanding lake ice on Maine's lakes, and also a little bit of discussion over the LSM data set that has been compiled over well before my time and even from some other organizations, and then continuing on now. So, for those of you who aren't aware, Lake Stewards of Maine, our mission is to protect Maine lakes and to promote lake stewardship through widespread citizen participation in the gathering and dissemination of credible scientific information pertaining to lake health. What that really boils down to is we do a lot of work with community volunteers to accomplish the science of collecting the dispersed data from around the state. We are a 501c3, and on that note, help continue to make our work possible. Both ourselves and Maine Lakes do good things. And so if you're able to donate, we appreciate it. So I want to frame the issue of ice. And I started thinking about it as these sort of three big aspects of when people see the ice out there. There's the coverage, there's the thickness of ice, and then there's the cold. And so from that, we're jumping off. So we have the coverage, which is this idea of if you have ice out there, the sort of patchy structure of ice, it's not going to necessarily be something you're going to walk on. This is a safety issue, obviously, and you might have some level of interaction with the lake still, but you're likely not going to have that sort of idea of the ice well set up um, and stable enough for wintertime activities, things like that. The important things to note here are also the historical context of having sort of that coverage and also the safety aspects of seeps. So areas that have water running into them or seeps from groundwater usually are going to be more likely to be open. Um, Interestingly, the open spots, open pockets can allow for reoxygenation, but inversion, which I'll be getting to a little bit later, a principle of limnology or lake science, is um, really not going to take place with that. And so if you don't have inversion, you're not going to get a significant reoxygenation of lake waters. Um, so just with that in mind, the historical
They come out
context,
this time
ice
of
has been a
night
big
once it's
part
getting dark.
of lakes here in Maine and the history of Maine. We have a tradition here in Maine of harvesting lake ice. The peak was in the 1800s, and tens of thousands of people were employed throughout New England. Sort of a famous thing, packed in sawdust and shipped around the world. Maine ice was seen far away. The Thompson Ice House Harvesting Museum actually this Sunday is having their demonstration event of harvesting ice, and you can go see that. So I thought I would just share that with everybody. So then the thickness. The thickness of ice, again, there's a safety issue, but this is purely a function of thermal energy. Unlike the spottiness, you could have a big wind event that would open up a pocket, break up the ice some. With thickness, this is how much thermal energy is present, and as a result of it, your ambient temperatures, so day to day, your air temperature, and then also how much solar energy you're gaining is really going to impact this. Um, Interestingly, or an aspect of this is that the thickness, you think about it, as well as snow can impact both the light penetration. So there can be algae that actually grows underneath the surface of the ice. Um, and so if you have snow over it, or if it's really thick, you might not have that development. And you can also have, with both those factors, a longevity of ice. Snow acts as an insulating material, and obviously ice is a big old block of ice, so it stays cool longer. I really love this little image. This comes from the Minnesota Department of Natural Resources. Um, this was something they put out a few years ago to show thickness of ice and safety around it. So, if you have greater than 100 inches of ice, Godzilla can walk on it. And I really appreciate their humor adding that in. So then the cold and why cold really matters ecologically. And for this, I just want to have this nice little image of you sit there on a hot summer day, your nice glass of water with ice cubes in it, keeps it nice and cool. And I want you to sort of keep that in the back of your mind as we go through this, because a glass of water is going to be our analogy for lakes. So in order to understand this and why the cold matters ecologically, we need to understand how lakes work. So important limnology that goes along with this is that we have in a lake three major layers that we talk about. There's the epilimnion, the metalimnion, and the hypolimnion. The epilimnion, you can read all through this in the recording at a later time, but basically it's the surface water. The metalimnion is your middle layer that is experiencing a rapid temperature change. This is where the thermocline is. The thermocline is your, crossword puzzle clue there or answer for that rapid temperature change area in a lake. And then the hypolimnion is your bottom water. So this is the area that isn't getting reoxygenated during the spring, late spring, summer period, and into fall when you have the stratified lake. Here's a little diagram. So you see the epilimnion, the metalimnion, and then the hypolimnion. The thermal stratification is really important for the lake because this is a sort of a fundamental aspect of how lakes function here in the Northeast. And everything we're going to be talking about is really discussing it within this sort of main context. So going back to that glass of water analogy, the important thing to remember with this is that if you have a stratified lake, so that thermal barrier between the surface water and the bottom water, you're not getting oxygen down in those bottom waters. And just like a can of soda, if it's left out on a counter and it warms up, you're going to lose some of those bubbles. This is a physical process. This is just as things warm up, they can contain less dissolved oxygen. And that's what a number of our volunteers actually measure with dissolved oxygen meters. They put them in the water, they're going down through the different layers and seeing how much dissolved oxygen is at each depth. This has implications, obviously, for things like the cold water fisheries, so fish that definitely depend on it, as well as some chemical processes. The important sort of, I have a series of images here, and the important thing with each of these, hopefully they're fairly easy to understand, but it is the red color is warm water, the blue color is cold water, and then the purple is sort of your in between. And so I'm going to be going through these sort of 5 scenarios to help understand this. So with this sort of demonstration image, we have an early season gentle warming of the lake. So you have a sort of thin band of warm water near the surface. It's not very mixed, and there is sort of a little bit of a wide thermocline or metalimnion there. So it's not a super strong metalimnion. And there's a lot of cold water in this example. The second one, you have either a gentle middle of the season, so this is maybe towards, early July, something like that, where you're seeing a little bit more of the water column is warm. This can also happen in a later portion of the season as it's warmer water, but there's been a lot of wind that has been mixing it up. So we have that sort of very wide, and I'm not sure if you can actually see my mouse on here, but we have this sort of wider band for the thermocline metalimnion area. And then we have less area that is cold water, obviously. This scenario we've been seeing a little bit more, especially nationwide, it seems, that we are seeing a very rapid warm up in water throughout the lakes. And so you have this very warm water near the surface. You have a very strong, thin thermocline. And so this barrier here is very hard for things to pass. And even though we might have water down here that is cold, because this barrier is in place, you're not getting any reoxygenation ever. This might be something you'd see on a very hot summer. A very significant region of the water column is warm. You're having a lot less of it with cold water. And as a result, your sort of thin metalimnion means that there's a strong difference between that very hot water and that colder water. And then finally, this is what we generally see in the fall. This is where you have your warm water that's been up at the surface is starting to mix because we having a lot of colder nights. And so that water is inverting, also known as lake turnover, and it's all mixing up. And we get a lot of reoxygenation at this time. This is sort of what I alluded to earlier with inversion. This is your process by which that bottom water, which was not oxygenated very well because respiration is happening down there, and fish are down there breathing and things are digesting, all of that stuff. All of that is happening. It's all pulling oxygen out, and until you have these sort of big inversion events, you're not getting that oxygen water reoxygenated. So the takeaway with all of this, and going back to the ice idea, is that if you have a much bigger ice cube in your cup or our lake, then it's going to stay colder longer. And this is really critical for the health of our lakes. You see less algae growth in the colder water conditions. There are some, nuances with that statement, but overall, you're going to see a lot less of those big cyanobacteria blooms because it's colder. You're going to see a lot less respiration taking place in the water column. You're going to see a later period when that thermocline sets up. So you're having that barrier between the surface water and the bottom water set up. And because it's colder, water, you're going to it's going to physically be able to hold more dissolved oxygen. So getting to our surveys of ice data, you can see that these are all of the surveys that we have within the state. So these are reports that people have taken, sent in to us. There is some data like USGS that's been included in this data set, and some water districts as well. So all of that is sort of compiled here, and you can see that we have a sort of good distribution across the state. However, you'll notice that there are some gaps in our data that I've highlighted here with the red arrows. We definitely know there are lakes in some of those regions, but partially this is a function of less population density. Partially, this is a function of um, not having volunteers in that area. We have a lot of volunteers right down in this sort of greater Portland, Augusta region, um, going up a little bit towards Bangor. But in general, as we start to go further north, we don't have nearly as many volunteers just across the state. Again, that's a bit of an aspect of density. Oh, also, if you are in any of these areas, or you're watching the recording later, send us your observations. This is not something that you need to be certified for. This is something that we welcome reports from people in the community. Even if you go by a water body and you're observing the ice cover has come on to a water body that might be on your drive to work, or you're going to visit family on a frequent basis that's 4 towns over, and you go by a pond. We want that data. We have some ways of sort of filtering out what the earliest reports are for that data. So it's better to have the data and then have to clean it a little bit more than to just have these gaps. Um, then you'll also notice that we have a lot more open water. So those are the blue circles versus the ice in reports, which are the sort of light blue, aqua colored squares. And partially this is a issue again of population densities and some things like that, whereas like USGS and some of those reports that we have, those have a lot of the open water reports. We don't have that in some of these cases because there are not people living there. The other major aspect to this, and this goes back to sort of that cultural tradition, is that at the spring when ice was, fall shrinking down, there was less and less ice on a water body. That was a celebratory time for a lot of communities historically. And so we have these reports of open water. We sort of have the spring festivities and a lot of sort of activities that are getting going and commencing across the state in the spring, and people are outside and observing. You have a little bit less of that, in the fall. There's autumn festivals, obviously, which are celebrating the harvest and things like that. But you don't really have, well, it is time to, the ice has finally gotten thick enough so we can go ice skate. There might be internally, like at small groups, people's, have memory of that. But in terms of recording it, it was a little bit less done. All right. So just the other quick thing that I'm going to talk about is discussion of sort of the natural time scale versus the anthropogenic or human-caused time scale with climate change. I will say the disclaimer that I'm not a climatologist, but these are sort of the important aspects, or I think the most important aspect to remember with any sort of climate change discussion related to things like this, which is that the start of the last ice age, which is known as the Pleistocene glaciation, was 2.58 million years ago. And our last glacial maximum was 27,000 years ago to 11,000 years ago. So we go through these sort of natural stages, but what we're experiencing now, you can see, is a 200-year, less than 200-year period where we're seeing very rapid global temperature increases. And so this is really sort of an important frame to always have is that the climate change that we're talking about is the climate change from human caused or human driven, and there might be natural factors that are also playing roles, but this is definitely something that is new and is not a naturalized phenomena or a natural phenomena that's just going through the normal cycles of ice age periods. All right, time to look at the data that we have. And for that, I'm actually going to be switching my screens here that I'm sharing with you. But I do want to put out this sort of warning, which is that this is a simple trend analysis and a data visualization. It is not meant to be taken as a scientific research grade finding here in this format. If you want to have more discussions about that, we are working on things along those lines. There are also researchers who are that is their major focus. You're welcome to contact me, or you can also, if you're interested in getting a copy of the data set, you can reach out to us and we will share that with you. That is what we have it for. This is a public data set, and we want to make sure that that's available to people who are interested. So I'm going to stop sharing my screen and jump over to the other one. All right. So hopefully you can see that here. This very simply is, this is a program called Tableau. It's a data visualization software for the most part here. But what I have here displayed is we have our three sort of major categories that we, or our three categories that we talk about within ice data. It's our open water, our open pocket, and our ice in. So this would be, when ice is coming on. And you can see that this is when they occur based off of a shifted Julian day calendar. Julian day is 365. And so we're counting from 300. So January 1st would be 1, January 2nd would be 2, all the way up through December 31st. And depending on the year, also including leap years. And so because of that, it causes a little bit of problem because we have this sort of 2-year spanning data set, because you have stuff that is taking place in the fall. You might have some lakes that have ice on in the fall, and then you might have some lakes that don't ice on until January 3rd, for instance. Or unfortunately, this year we've had some really late reports of like January 10th and 20th. So things like that, we require the whole shifting. So right here we have 365 days. That's your January 1st. And so everything after that is going to be your period going into February, March, April sort of thing. And so you can see that most of our density in terms of our, and this is just a heat map showing, the darker the color means that there's more recordings on those dates. Most of our recordings of when ice cover has come in is all around this sort of period. And this is not broken out by year yet. We have another plot for that. And likewise, we have within the shifted Julian days, this is when most of your ice out is occurring. So, you can see that most of our ice cover is disappearing here. The ice pocket or open pocket recording, that is a more recent form of tracking, and there is a lot of subtlety to that. So it is not included in this next set of data, but it is still an important component that we are recording when available. So here we have a ice in data visualization. This is that very simple linear trend analysis. So we can see that some of our earliest numbers here for ice in dates are 1937, and it was 343 days into the year of 1937. So this would be early, let's see, that would be early December, approximately, for the 1937. And you can see that in 1912, we had a ice in date that was very, very late on one lake. So these are all of our samples that we have for our ice in dates. And the sort of important thing to see here with the trend analysis is that even though we have a huge amount of variability, we are trending overall towards a later period for ice in. And I think that probably most of you on this call or watching this recording later are sort of anecdotally witnessing that as well. So we have seen this past year and in the previous year, and in several years before that, that overall the dates by which we are seeing ice cover come in are much later. The stories that we might have from, your parents or grandparents or great grandparents were like, oh, yeah, I remember in, you know, 1912 when we had ice on the lakes um, in early October. And maybe that's so. We do this sort of analysis because those anecdotal stories are unfortunately anecdotes. They could be one-offs. It might just be that that was a really cold year. In the 1800s, or sorry, the 800s, there was large amounts of 18 wow. In the 1800s, there was a large amount of ash thrown up by the Krakatoan explosion, and those sulfur crystals went up into the atmosphere, and they actually caused a cooling of the environment globally that was observed. So everything has to be balanced sort of within those contexts. For the ice out data, we have a little bit more, and I've added also some, dates on here so that you get an idea. And the important thing to recognize here is that we're seeing a significant shift towards earlier and earlier ice in or ice out dates. So, some lakes are seeing their loss of ice even in December, November, things like that. Um, Always the caveat with this is that these might be ice off, and then there might have been a later freeze that we didn't capture. So even excluding these values, we still see that there's overall a significant trend towards earlier ice off in the year. So um, rather than around May 1st, where we might have seen it in the 1890s, it might be more around um, April 15th in 2023. So that's sort of what we're looking at and what we're discussing with all of this. And there is a important iteration that will be coming out of this data set, which is total coverage dates. That's sort of the ideal that we want to get to next, which is the showing that how much time was a lake actually covered in ice. And so that takes into account the ice in date, any times that the ice became open, so those pockets, and then the ice out date. And with that, we can say, well, the ice thickness might be less. There's all of this. The important thing to remember with anything dealing with lake ice data is that it is acting as a proxy for the overall climate, and it's acting as a proxy for the potential implications that that might have on the lake with trends. This past year, we saw a huge amount of rain and a very cold spring, so we didn't have the same amount of algae growth in many of our lakes that we saw in some other years where it was a very early ice out and it was then very warm. So there's always these different aspects, and these sort of proxies are not infallible, but it's an important thing to help us inform the discussion. And that's where I'm going to be leaving it.
Awesome. Thank you, Tristan. That was a ton of information and really interesting stuff, especially, I don't everybody seems to be, I mean, everyone I talk to when you're making small talk, these days is everybody's commenting on this weather. And people can't go smelting because the rivers aren't frozen, and people can't do their usual ice skating because the ice is too thin. So it's definitely a fascinating topic. So
Yeah.
if people if people want to unmute themselves, you can unmute yourself, turn on your video. Feel free to, you can use the raise hand function. I think I can see everybody too, so you can also just physically raise your hand. And feel free to ask Tristan any questions you want.
I'll jump
Yeah, I
in.
see Stacy.
Yeah, that's fine. I had put something in the chat. I didn't know if you
Oh, I
wanted.
just saw that now.
Yeah, that's
Thank you,
okay.
Stacy.
Sorry, I'm multitasking, making dinner here at the same time. But thanks for this presentation, Tristan. And I I was particularly intrigued with it. I do some, I know Susan, and I do some work with the aquatic invasive species groups, but I am an ice enthusiast and I am a skater in particularly in remote areas we enjoy, and starting around Thanksgiving, we go to remote lakes and ponds in Maine. So my question is, how far back would you like data? Because I have lots of photos and probably good estimated measurements of ice in on remote ponds in those areas where you had the red arrows. And I'd be thrilled to be able to put that to use somehow.
Yeah, that would be great. There's also some folks with the University of Maine Farmington who might be really interested in that data. Oh,
Yeah.
Julia is there? Yeah. Um, so yeah, I think that that would be wonderful, and yeah, we'd love to have it. Anything you have, we can certainly talk more offline about any specifics that come with that, or looking at the data and how we might quality assure it.
Sure. And yeah, there's this growing group of Nordic skaters and ice enthusiasts around, and everybody's kind of via social media sharing that information, which can be good and bad, but just thinking on how to empower or educate the recreational community to contribute to science while they're out. I call it recreating with purpose. And same with, I go to a remote area camping or something and I do a bird count, I submit it to eBird, and then it goes into a data set. So be happy to talk more about that. So
Yeah, that's wonderful. And I mean, yeah, there's some great stuff. You also mentioned the social media aspect. I know that there are definitely researchers nationally and internationally who are trying to use, you know, doing these sort of data crawls through social media to capture things like that, of, people being like on social media being like, hey, look at this, the first buds of spring, or and really doing a lot of that phenology study. So yeah, I think it's great, and I really appreciate it. And I think Julia just put into the chat a link to
I see that.
their data
Okay, cool.
submission. Yeah, thank you.
Anybody else want to jump in? You can ask Tristan anything.
Well, I'll
Hi.
ask, someone else wanted to go. Does somebody else jumping in? I didn't want to.
Oh, this is Julia. I was going to jump in really quick. I actually had a question about the ISON observations. I know sometimes people want, when they're reporting ice out, it's sort of ice out from a particular location, like looking at a particular view. When you're getting the ISON stuff, are you hoping to get sort of consistent reporting with that?
Yeah, it's one of the real difficulties of the data set. So we have some metadata saying how those recordings were performed for some water bodies. And people will say, like, oh, well, it came from this cove, or, the entire water body is now frozen. And if there's a new water body that's coming online, my argument that I try and put forward is to do visual observation station and just to call it from that point. And so for anybody who's on the call right now or watching at a different time, very simple sort of process. You take a 4x4 post and you put it in, sink it in some concrete on a part of the land where people can access it or community can access it, or even just somebody's private property that is willing to have a long data record there. And then you can take pictures, and then you have a visual record that goes along with it. And I didn't talk about this exact within our specifically when I was going through my presentation, but our data submission form does have the capability to submit a photo with records that are being processed. So we are using the Survey 123 platform for data submission, and that allows people to go out, take a photo, record it online through that portal. And those are found on our website. And I will maybe at the end of this just throw up a link to that.
Are you using satellite imagery at all?
So we are not. This is so the data set has been used in some of the ground truthing work that is being looked at for satellite imagery. I can't say exactly where that stands. There's a couple of different projects that have been ongoing, and the data has been used for those. I believe University of Minnesota is currently working on a satellite image set and using our data as a baseline for some of that. So for basically a learning algorithm, so that it can then say, well, this much we're witnessing these things. There's a lot of, from my understanding, there's a lot of things that are really tricky with that form of remote sensing, including things like snow cover, clouds, shadows that form, reflectivity off of, maybe you have open pockets and you get sort of a reflection from the sun, which can then be interpreted on a visual basis as ice because it's also white. So there's a lot of things, and I don't know all the specifics of how those algorithms that are being developed are being used. We're trying to ensure that the data that we have is high enough quality that it can be used for those purposes.
I have a question about the impacts. I know you mentioned algae growing under the ice, and I've seen Ben Pyral's videos where you can see it under the ice, which is fascinating to me just on its own. But do you have any thoughts about if there is? I'm just wondering about the implications from climate change and implications from the lack of ice, or less ice or no ice or less ice from an water chemistry or ecological standpoint. And I know that's like a huge question, and there's probably many theses worth or dissertations worth of questions in there, but just I don't know, I'm always trying to think of ways to make climate change make people pay attention to climate change, and telling them, for example, telling them that loons could leave the state if climate change impacts of warming water continue. So that, like, those kinds of things that I think grab people's attention. Is there anything related to ice that you feel comfortable
Yeah,
you or
well,
Julia feel comfortable sharing?
Yeah, I mean, I think a lot of it does go back to that idea of if you're having cold water for a longer period of time, it's really it's having this multi-fold positive impact for what we have historically established in our lakes, which is cold water fisheries. There aren't many places in the southern United States that have cold water fisheries, and so the things like the salmonoids, they need that. Arctic char are one of the few species. We have populations of Arctic char, and I guess again, I'm not a fisheries biologist, but we have populations of Arctic char, which is a rare species. I know that Mary Gallagher of the IFNW, Maine IFNW, we are hoping to maybe have a presentation from her next winter on some of these really rare or interesting fish species in our state. Things like I might be off basis, but red darter I think is one that she's mentioned before. And so some of these small interesting fish that we just don't have very good data on. And we might lose some of the fish species that are really important. And with that, there can be cascading impacts, such as the loss of loon populations if they don't have appropriate food. Or one of the biggest ones that I deal with a lot is the fact that if you have really warm water and it has less oxygen in it, especially down in the bottom waters, you get a chemical reaction called internal loading. This is where iron, which is a very common element in many Maine lakes, is bound to phosphorus, and that bond breaks, meaning the phosphorus is then available, which means that you get this sort of positive feedback loop where you get more and more algae growth potential. And then you have a green, scummy lake, which requires things like alum treatments to start to put back in place, which are very expensive processes. So there's a lot of, I think that a way to really think about climate change and things like this ice coverage is that they give you better, as the water's warm, it makes you less resilient. And so other things you can do to limit the impact on your lake are going to be very beneficial. However, if you have, nutrients in the lake already, and you're having warming waters, well, that might be the thing that finally pushes it over the edge to now have a lot of green algae or cyanobacteria growth that most people don't like going swimming in. So,
Right, right.
yeah, Julie, I don't know if you want to add anything. This is meant to be a bit of an open forum at this point, so.
No, I can see Ross has got his hand up.
Okay, wonderful.
Oh yeah, Ross, go ahead.
Yeah, just getting back to the social media aspect, I wanted to put in a plug for a Facebook page that some friends of mine run called Ice Thickness in Maine. And they keep a tight rein on the drama. There's no arguing, there's no bullying. Just if people want to know what the situation is or for thickness of ice, or if they want to let people know how thick the ice is on their pond, it's a good place to go for that information. I put a link in chat.
Wonderful.
Thank you.
Thank you, Ross.
Yep.
Yeah, and that's it's something that we don't have very good data for at our organization, is just the ice thickness. So, you could have ice coverage on a lake, but it could be that it's a fairly thin skim. And generally, you're going to see that break up if there's a big wind event, or you're going to see it leave quickly, retreat quickly if there is warming, conditions, or there's a big rainstorm, things like that. And so if you have really thick ice, it's going to be resilient to sort of those weird sporadic rainstorms that we've been having a lot of recently in the middle of winter.
Right, that's a good point, because Tristan, when I explore different lakes and ponds, there's bound to be some open water somewhere. And so what percentage of coverage is considered ice in? Like for instance, a few of us are pretty excited to get on Tunk Lake this year. We didn't think it would happen because it's so deep, but we skated it last weekend before it got too warm, but there were some holes, but well over probably at least 3/4 of the lake was frozen.
Yeah. So our sort of large guideline that we're sort of going off of is 95% of the lake, which means that, and that is partially also a mental guideline, I would say, more than a hard quantitative guideline, because people think of something and they go, oh yeah, well that's about 95%. It's a much easier number to conceptualize than being like, well, 88.2% of the lake cover. And it's like, so we sort of say this sort of 95 number. That said, we have some water bodies in our data set that it might be, oh, there's a cove that never freezes over. And we just don't even worry about that cove. That cove has a lot of wind, or it has a seep, or there's a big raging, inflow into it. And so it's always a little bit of a nuanced discussion regarding that. But one of the things that we do tell our volunteers who are capturing ice data is that if there's an established methodology on your water body, you should continue following that method. So if it's, when the two major bays are, or the two major basins are iced over, but that third one isn't, and that's what you've been tracking since the 1960s, then you keep tracking it based off of that. And while that doesn't necessarily make it sort of calibrated to other lakes, there's a lot of other factors that impact lakes, such as elevation, or even sort of the regional aspect of being near the coast. And so for those reasons, the measure of what we're seeing sort of at a grand scale is the important thing, and trying to keep a consistent methodology. If people are interested in doing something like setting up a visual, a photo station, something like that, what we ask is that they continue doing the old form of observation for maybe 5 years and switch over to the new one. And so they're capturing it both methods, so that we are able to have a cross-reference analysis between the two different methodologies.
Actually, that to follow up on that, Jan Slack put a note in the chat. She said, Tristan, could you say a little bit more about the observation point and how you would select the best spot? Which you sort of touched on some things just now, but is there anything else you can add for Jan?
Yeah, it depends a lot on the shape of the lakes. I mean, there are, some lakes that are horseshoe shaped, and getting a good observation spot might be hard for some of those. I think it's really important that you get sort of a community buy-in for wherever you establish those, because this being a sort of community science, and I mean, something we always face within our organization at Lake Stewards is that we have a fairly older population. They're the ones who are out there doing a lot of the volunteering, because they have the time to be able to go out in the middle of beautiful summer days and take those samples. And then as a result, they also are the ones who are available to do the other recordings and just part of our community. But they maybe can't do it for the next 20 years. And as a result of that, it's really important to make sure that there's community buy-in, that somebody is willing to step up and take on those responsibilities. And so having it on private property is not recommended. Having it in sort of like a community space, or next to a road might be, if there's an area that's sort of clear near a road, public access, things like that. Those are all important to think about. And then obviously you want to capture as much of the lake as possible within your photo sort of viewing station. Just so that you are, you're not seeing like, oh, this little cove is what we're basing it all off of, and maybe the rest of the lake is open water, but you're like, oh nope, this is what it is. It's completely covered, and it's just going to provide less accuracy with that. Or actually, I guess better, less trueness. It is accurate in that it's repeatable at that spot year after year, but it might not be true to the rest of the lake.
Good point. Anybody else that want to ask a question? I don't see anything more in the chat.
Right. Well, maybe this is a good time for me to just
Happy-
share with everybody.
Yeah.
I'll just go to our website real quick here and share that with everybody so that they can see how to navigate to this. So this is our website. In winter, we do have as one of these sort of in our scroller menu, we do usually have one that is sort of ice coverage, but we always have it under this volunteer programs and tools. You just hover over it and it will show up. And then you go down to climate change and ice data. And there is information here. One of the other topics that's come up a lot in the past few years is the wintertime variability. I have an article here that talks a little bit about that, of like what you should be recording, because, you know, maybe you had ice on last night and then it disappears and then it comes up back on the next day, you know, sort of that thing. And so the considerations around that. But this is the submission form here. This is the coverage map, which I had the screenshots of. Just show that real quick. Right here. And you can see that, you know, Lake Auburn was recorded as having, you know, these sorts of things. And Erica Kidd and Dan Fortin were out there and when they observed that change. So there's a shout out to Erica and Dan. And you can also do things like click on individual things in here, and it will provide you information on, these are all the Wessarunset lake right there. And here we have Kingsbury Pond. So information can be found there, as well as the dates. And information, or the sort of directions, are right here at the top. So that's quickly that. And then the ice coverage sort of survey form. It's built in right here. You can fill out your MIDAS, who you are, who's submitting, the lake name, the town, the county, and then observation. This will allow you to jump to it. So, you know, if I want to say Pushaw Lake in Glenburn, there we go. Shout out to Pushaw Lake, just north of Bangor there. And date you witnessed ice cover change, and then sort of if you want to include time. You'll notice that some of these fields are required with the little star, some of them are not. And then also what you witnessed. Did you witness ice cover, mostly ice coverage, partial ice coverage, or mostly ice out, mostly open water? So additional sort of fields that you're welcome to fill out if you have that data. And then the only one that we need within those is the who the person actually is that did it, and then email address so that we can contact them. And this is where you would add your image. So you could drop your image here if it's on a computer, or take an image there. So
Very cool. Well, awesome. And unless anyone else has questions, we'll end it. But thank you so much, Tristan. And as he mentioned, March 7th, 5 o'clock, if you want to hear about crayfish. Karen's a great speaker, and I'm sure she'll share great information and insight on crayfish. So hopefully you can come back for that.
yeah, thank you all. And as I said, if anybody is interested in getting the data or looking at the data, my email address is tristan@lakestewardsme.org. There will be a recording that we're going to post later, and we'll share with everybody who's on the call currently.
Yeah, I'll send it out to all the registrants, because somebody's just trying to join now, and I feel terrible because they did not get the message that it was 5 and not 6. So I will send it out to all the registrants, along with an apology for our confusion over the time. But 5 o'clock next time.
All right.
Thank you, everybody. Good night.
Thank you.
Thanks so much, everyone. Take care.